Hello guys, welcome to another video. Today we will talk about another really important topic in Swift, generics. What are generics? Why we need them? How to solve problems with generics? And another really important question, can we use it in SwiftUI? So all those questions will be answered today. So let's get started. My name is Pete, and yes, this is Swift and Tips. Alright, let's answer first, what are generics? In short terms, basically generics help you to write flexible and reusable code. That's it. There's no more boilerplate about it. It's also one of the most powerful features in Swift. They are all around the language. Actually, if you're kind of new in Swift, probably you have used already some kind of generics without noticing. So yeah, it's one of the most important core features in Swift, and I think most of the languages also. And according to Apple, this is kind of a polymorphism, more specific, called parametric polymorphism. But okay, so yeah, we have generics. What is the problem that generics solve? Let's try to build something really simple, a function to say hello, alright? Let's do it. Now, what we want to do here is pass a value, okay? In this case, let's pass an integer. Okay, this is pretty straightforward. However, as you notice, we are using int as a parameter. But what will happen if we want to add also a string? Alright, let's create another say hello, but in this case for a string. Pretty cool, right? Okay, now we have coverage for int and string. But what about doubles? Yeah, let's add another function for doubles. Cool, but what about floats? Yeah, let's add another one for floats. Okay, something is complicated here. If you notice, I'm just copying and pasting the same code over and over, and the only difference here is the type that I'm using. First, yeah, copy and pasting many times the same thing is not good, right? It is just a basic example, and as you can see, I'm already in problems with this. Yeah, this is actually one of the issues that we will suffer without generics. Generics provides a way to simplify and generalize the type we want to use, in this case in a function. We will see in a moment more about it. But the thing here is that you can just forget about the type in this case and just say, okay, I will do some task here and I don't care about the type. If you do care about the type, don't worry, we will talk about it in a moment. But okay, let's fix this. We want to say hello here, but I don't want to write a function to every type in Swift, right? This is impossible. So what I'm going to do is actually create a generic function. How to do that? It's really simple. Let's again invoke say hello. But now, before the actually parentheses, I'm going to use brackets, okay? And here, I'm going to specify something called type parameter. What is that? It's basically a placeholder for your type in order to this function to understand what is the actual name of the type you want to use, okay? But this name is not a concrete type, it's just a placeholder again, right? So one of the common things to use is use t to reflect time, to reflect that is a type, right? We don't care actually, in this case, something more meaningful, okay? There are some other cases that we will cover in a moment, but in this case, we just care about, okay, any type t will be provided, and I will do something with a variable of type t, that's it. So let's now work with the parameter. So in this case, I'm not going to specify anything in the argument label. The only thing we're going to do is just again use value and specify that value is type t. That's it. I don't care about the rest. Now, let's put again our print value here. There you go. And let's run it. Okay, let's say hello for number 4. There you go, it's working. What about strings? It's also working, great. And what about doubles? Awesome, yeah. Yeah, as you can see, this function is working without worry about the type, okay? So this is a really straightforward example, but the idea is, again, avoid this kind of duplication. When you found something here in your code that is concerning about the type, but basically the logic is the same for no matter the type, is a really good signal that probably you require generics in your implementation. So yeah, let's see some other examples. Okay, before continue, probably some of you could have a question. Instead of using generics, why not using any for everything? Okay, let's analyze this. Let's try to do the say hello function, but with any value. Any is basically that representation of literally any value, any type, right? So any kind of object that you want to pass with from here will fit the requirement, okay? It doesn't matter if it's a class, a struct, a num, closure, whatever. Everything will fit here, okay? Yeah, you can say in this particular example, okay, any is working. Why should I use generics instead? Yeah, this example could be kind of controversial, but it's a really basic example. In reality, you will have to use more concrete implementation, more dynamic code, right, in your logic, not just saying hello to everything. But if that's the case, then you will lose a lot of flexibility if you use any. So let me show you something really cool. All the collections in Swift are actually generics. Yeah, let's see the case of array. Let's create an array of any. Normally you use this shorthand syntax, but actually the type of this array is array, but it's an array of any, because any is the concrete type. If we go back here to array, we will see that something called element is actually between brackets. This is also known as generic types. And array is basically saying that anything can fit in this struct. So this is good. We already know that we can create any kind of array, right? But in this case, instead of using a concrete type or an array, let's use any that allow us to put basically anything here. Let's put some random examples here. Yeah, here we have a bunch of random items, right? All of them are from different types. The usage of any actually has some kind of trade-off. One of them is that we are using extra memory because we are basically boxing every value here because we don't know, well, at this point, we don't know what is actually the concrete type of every element here. That's an extra work unnecessary in this case, and also necessary for our simple example. And even worse, if we want to use any of these elements here, well, we will have to unwrap them. So let's unwrap the first one. And yeah, it's working, but remember that forcing a cast is really dangerous. So don't use it so much. Or even worse, yeah, since that any can fit any type, so if we modify our number 1 here for a string, we'll get a crash. So this is not good. So yeah, any is a special type just to reflect any value, but don't use it in your regular implementation unless something really specific is required. But don't use it as a replacement of generics. Generics exist for a reason, and this reason is to simplify our code for multiple types. We just saw in the say hello example that we can use placeholder types and work with any type. However, what happens if we actually require to some specific subset of types to work? We don't want to work with everything, but just with a subset. Yeah, it's also possible with generics. Let's see an example. Let's create a method to sum two integers. Yeah, this is pretty straightforward, but it's only working for int, so let's transform this in a generic function again. That's it. Whoops. But look at this. We are using add operator here, but we cannot use it directly with any type. So we need to restrict the usage of this type t to just be a subset that can fit in this requirement. To do that is really simple. We just need to constrain our type to something really specific. If you're using classes, could be a superclass, but if you're using structs or enums, it's more convenient to just reflect that we are conforming to a protocol that provides any capability. It's the thing we will use here. So there is a protocol called numeric that is basically confirmed by every number type in Swift. So if we restrict this just to numeric, there you go, the issue is gone, and now, yeah, this is working perfect. So let's try this with different kind of numbers from different types. Yeah, as you can see, we can work with ints, we can work with double and floats, and actually we can, in this case, combine different kind of concrete implementations because all of them are related to numeric protocol, which is great. And now, what will happen if we use a string here that is not confirming numeric? Well, logically, we will get an error because, yeah, this is not confirming numeric value. Yeah, and the error here is reflecting that. So yeah, if we need to restrict our type right away from the type parameter, it's really convenient just to use this semicolon syntax and then follow by what is the type constraint that we need to force here. In this case, it's a protocol again, but also for classes could be a parent class. We already saw that array contains a generic type for handling all the types possible, but we can do also that for our own implementation. I bring back the stack example from protocols example, but in this case it's a struct. Here we have a stack of ints. It's cool, but we want to use this kind of stack for everything. So let's transform this in a generic type. Like functions, when we use parameter types, it's the same. Let's use it here. But here we will use the bracket syntax just immediately after the type name. Here in the middle, we will type what will be the placeholder name. However, in the previous examples, we use t as the type. But in cases like this, when your object is not so much simple like the examples that we saw earlier, it's really convenient to give a meaningful name here. So instead of just a t value, let's actually call this element value. Yeah, because this stack will contain an array of elements, and later in a moment I will show you that this is actually a common pattern that you already saw in array, that array is conforming also a placeholder type called element, and this has some advantage when you want to extend from another protocol that are already using this kind of name, similar name. So, but for now, let's replace int type for element type. There you go. Now we have our generic stack. Great, so let's try this. Let's create a stack of ints. There you go. This is the way to declare and initialize this stack of ints. So now we can use it, so let's try it. There you go. Now a stack of ints contains the values. It's great. Now let's try this example, but now with strings. Awesome, we just now become great Pokemon Master and we got the 3 legendary birds in our stack. It's great. So as you can see, we can now use any kind of type for this stack. And this is really convenient because the stack operator shouldn't care about the type. So yeah, the type is just something that we need to care in some way, but it's not important for or relevant for the context, okay? Remember that you can also constrain your type to be specific for a subset of types. But in this case, we don't care. In this case, we want to make operations with any kind of type in our stack. But it's again, if you want to apply a type constraint for your generic type, it's just really simple. You can just set numeric or whatever type you want. So yeah, if you do this, yeah, your stack will be forced or restricted to just particular set of types. But this is not the case. So really cool, right? We can extend a generic type, and also we can get access to the placeholder type that we already defined in the beginning. Yeah. In this case, we can get access to elements from the extension. Let's see that in an example. Let's actually create a computed property to get what was the last element introduced in our stack. To do that, we need to get actually that element. So let's see that. But remember, in this case, the stack is handling element type, which is a generic type, okay? But look at this, element is a variable here. It's cool. And since that we are handling the last pushed value, it's just as simple to return values.last. But this is an optional, so it's better to mark this as an optional. Finally, let's try it out in a print statement. Cool, yeah, this makes sense because the last value already pushed was maltreous, so yeah, the result is maltreous. Yeah. As you can see, extending a generic type is really simple. And as you might notice, creating functions or types, generics, is also simple. Before ending the video, I want to give you one last example, but in this case using SwiftUI. I think it's important to you to understand that you can apply this in real life, because I just give you an introduction of generics, but actually, yeah, generics are everywhere, like I mentioned. What we're going to complete here, let's create a car view that will have a background view, and we will display in the middle of the screen a car view, and inside we could apply any kind of view that we want to render. In other words, we want to display something like this. And when here we have a background, in this case a green background, we have the card, and inside we could put whatever we want. We could put a text, like this case, we could put a text field, we could put an image, whatever. A custom view provided by you, whatever, it's up to you. To do that, I will share it with you in the description a background gradient view that I already showed it to you in a previous video about understanding your view without seeing your preview. This is a code. If you want to pause the video right now and you want to code this by yourself, it's okay. Otherwise, let's start. All right, what we can do here first is, well, providing the view, right? The view that we want to display here. Okay, let's do that. Oh, but we just found a problem here. Protocol can only be used as a generic constraint because it has a self or associated type requirement. Yeah, this error is pretty common, and I'm seeing a lot of Swift developers not understanding what is happening, although in this case, the error is self-explanatory. I will talk more about this issue in the next video, but this is basically telling you that this is a special generic that you cannot use as a type. You cannot provide any object from this type right away because this is a generic constraint. What this means is that, like we saw with numerics, this should be a constraint, yeah, a generic constraint. This view is designed for that. For now, the way to fix this is basically creating a generic. Let's create a generic. And since I don't want to call my generic view because view is already taken, I will call this content, which is a pretty common pattern followed by SwiftUI. And let's apply a type constraint to this content to be view. In other words, content will be restricted to be conforming a view protocol. And we can replace this. That's it. Yeah, it's complaining about this. Let's fix that immediately. All right, we are good to go. Now let's continue with our logic. Let's add the background gradient here. First, we will require a C stack. And we require a color. I will choose green. Let's try to compile this. Oh, we got an error. Let's fix it. Okay, let's show the canvas. Okay, the gradient is working, cool. Now let's add our card view. To do that, what we require is only creating another C stack containing a white card and then provide the content, which is in this case our custom view or parameter to represent any kind of view. Let's include our content view here. There you go. We have hello here, which is the placeholder text that we are providing from this content parameter. Let's increase the font to 50. And this is not looking as a card, so let's add some coordinate radius of 20. Cool. Now let's add some padding in order to distinguish the background and the card. Let's add 20 as value. And finally, let's add some shadow. Let's use a shadow with radius of 10. There you go. We have our card view right away here in the simulator and in the canvas. And as you can see here, you can provide any kind of view. So let's use another one. Cool. Let's add an image now. Excellent. Now we can use this card view. Actually, let's rename this as card view. All right, we just use generics in a really easy way in SwiftUI. Awesome. That's it for today. I know we need to cover even more about generics, but yeah, this video will be huge. In the next one, we will talk about protocols and associated type, because they are really important and are also another way to implement generics. And by the way, SwiftUI, well actually Vue in SwiftUI is using this feature, so it's really important to you to understand what's going on behind. But for now, I would like to say thank you so much for your support. Don't forget to subscribe and leave your like if this video was useful for you. And also, let me know in the comments what you think about generics. What have been your experience with that? That's all for me. So thank you one more time and have a great day.